So anyway, let's get started. The editorial is going to be in English only. For some services, we are going to have slides. For some, we don't have slides. You will have some descriptions of the services afterwards when we open the repository on the GitHub. But for some, you won't see this. You can always ask me or other developers, or write to info@ructf.org. And let's get started. So the first service is Environ by Max Muzaffarov, and it was written in Python 3.5, and it consists of two parts. One part is web page to show dashboards, and the second part is service as server, which works with Wi-Fi directly. And we work with Wi-Fi, and this is open environment, and we cannot trust anyone. So we should sign each packet with RSA protocol, and we should also encrypt all our traffic using Diffie-Hellman protocol. And for simplification, we used slightly less numbers. So modulus was 64 bits wide, and checker's private key was 32 bits wide, and you can read the rest. So there were vulnerabilities, and the first vulnerability was connected with this Diffie-Hellman protocol. If the private key is 32 bits wide, it's actually impossible to hack this private key in reasonable time. But if it's 16 bits wide, as it were in services, you can easily crack it in no time at all. And after the private keys are known, you can easily listen for put requests from check system and get all the flags. And the solution is obvious: just use logic key, just some 64 bits or something like that. Okay, the next vulnerability was connected with saving files. To name files, there was a function written called GUID, and it generated 6 random hex digits. And this is sloppy, and you just can brute force them all because there are not so many variants. But you won't know which are recent, and brute force is not a good idea anyway. So this was a vulnerability, but not a great way to earn some flags. And the solution, also obvious, use something stronger for generating random names. And the second vulnerability is path traversal in standard function of Flask framework used in this service. So there is function called show raw in the server, and it uses Flask's send file function. It's not recommended in the Flask because, well, it contains path traversal. But you can't access flags directly with this vulnerability actually, but you can steal the RSA key, and after that, you can send your packet. And check system wouldn't know that wouldn't differentiate between you and the other team. And the solution is to use the recommended function for serving statics It's called send static file. It's also in Flask framework. Well, and the next service is Meters by Blood. He's here. And the previous author, he lives in St. Petersburg, so he have already left us. So, this service, Meters, was written in Pascal, and it allows to make some public and private dashboards with some metrics. And let's get to vulnerabilities. So, the first vulnerability was the ability to brute force flags in the public dashboards. So, actually, there were several public dashboards from the check system, and they contain flags. They contain flags in sensors, but you're not given sensor directly. You're given some data and the result of linear combination of this data. And data is pretty random, so it's linearly independent, and you can solve it and get the flag using some math. Finally, math come to use. Okay, and the solution, one of the solutions is make data linearly dependent, so you can just solve these equations and get the flag. Well, it's logical vulnerabilities, so there are several solutions to work around this vulnerability. You can, well, figure out it yourself. And the second vulnerability was a cryptographic one. It was in the CBC mode of encryption. So cookies contained sequence timestamp dashboard, timestamp of cookie and dashboard, ID of the dashboard. And cookies were encrypted using RC5 and CBC mode. So servers checked if timestamp is not that far from now. 15 minutes or so. And if the timestamp is wrong, it's too old or too young or it's in future, it discards it. And for that, to get needed dashboard with some ID we want to use, we need to patch two sequential blocks, one for timestamp, for it to be correctly passed and not to be discarded. And after that, the ID of dashboards were willing to view. And so how would we do this? So we have encryption. This is decryption, actually. And we can do as follows. We can replace second block with the third block, with the third desired plaintext XORed with plaintext that is in the original plaintext. And but it actually garbages the second block, and we need it to be correct also. To do this, we would need to XOR the second block, the first block, to be the desired plaintext XOR resulted decrypted text in the first place. But in general, we don't know that decrypted text. But server actually told us what was the time you posted that was wrong, and this was actually this block decrypted. So we could use it to hack in the scheme and get two blocks decrypted as we want them to. Okay, but one block before that is trashed because of these manipulations, but actually in this method we don't use some block, and we can trash it, and that's okay. So the solution is don't tell the wrong date, so we don't have data to hack it. Well, and the solution everyone used, I think, is that was unintentional actually. There was a bug in standard library of Pascal in web server actually, and it contained path traversal vulnerability. Well, shit. Okay, the next service is Thornbox by Artem Daikov. He's here. And it was like saves with some pretty costly things, and it was written in Ruby using Rails framework. What of vulnerabilities? Well, the first vulnerability was actually a bug in the Ruby on Rails. It has CVE, and it is connected with rendering dynamic templates. And well, you can just read CVE for the details. Well, the solution was to update Ruby on Rails or refactor controller to avoid these templates. The second vulnerability was logical error. It was connected with that Ruby behavior. It actually is strange for a lot of people that 0 is true. Well, it's not obvious for everyone. And the vulnerability was connected with this. So look closely at this function. I don't know if you see it or not, but it checks some secret, and after check for length, so the secret should be right length, and after that it returns the size of some scanning result. And even it doesn't find anything, so scan result is 0, it returns it, but it's true. So the check is passed. So you just had to pass the correct length to this function, and it returns true every time. Amazing. Well, the solution is obvious. Okay, the third vulnerability was some kind of injection. In the update method, you can pass not just one ID, but actually a list of IDs. And the code would work perfectly and just updated all of them, all of the IDs. So you would just pass the ID of the secret private safe you want to hack, and just made it belong to you. Okay, but it works because in authentication, I guess, only first ID is actually used and checked. So you just pass your ID, ID you want to hack, and after that, write parameters to make the second ID belongs to you. Okay, and after that, everything belongs to us. Well, the solution is, again, code refactoring, more thoughtful authentication, and okay, that's it. So I'm passing my macro to the next service. Okay, this is Bay. He's awesome, and he's gonna tell you about the next service.
Hello, I'm Bay, and I need to switch the projector.
Meanwhile, you have time for questions. Do you have any question for these services? Yeah. Okay, Linux.
Пускай еще что-нибудь спросит.
1 minute. Linux is awesome. Gentoo is awesome. So, how was your day?
Давай так покажу. So my service was diskable. I don't see what happens on my display. So it consists two parts: the hardware part and software part. The hardware part is a radio 433 receiver and a TTL to USB converter. So it receives the data from the air and put it in USB port. So, and the second part, the software part is written on Swift. It's a language by Apple, which comes to Linux, which came to Linux recently, and it looks like this one. This, so it's a diskable. Yeah. Oh, if I insert the device, it's okay. So it prints okay, and it's just print flags to you. So actually, there no any vulnerability in my service. So you can see the flags, but it's a binary service, and to see you can see this only 10 characters of the flag, and to see the rest, you should patch it. You should disassemble it, and you should patch it. And I show its source. So it's Swift, and I show two places to patch. The first place is. Oh, yeah. So it's print on both function. So it's assembled text. And the print on both function just prints text on the ball in 3D. And you should replace this function with a print function. Just print function to see the data on the console, because it's copy-pastable and easy to read. So it's the first place to change, and the second place to change is I find done. No. So it's a substring part. Let me find it. Yeah. So you should change this constant. This 10, it's a 10 bytes. You should change it to something bigger, for example, with 40. And after this, you can see the flags on the console. Another way to solve this task was to figure out how the data encoding works. So this is a table of replacing the 4 bits replaced to 5 bits. So you can use this table and develop the same program using this table to get the flags just from your serial port. Only one team has solved this service. It was Bushwhackers. Thank you, Bushwhackers. And one more part. This is a radio module. It works better with the antenna. So you can use, for example, headphones from the, headphones like this one, and any wire, it's good. So 70 centimeters wire works the best. And of course, you can use it without any antenna, but it's better with antenna. And one more announcement. we have 25 transmitter modules for you. So you can take it just after the presentation. So if you want to disassemble it or something, play with it, you can take the transmitter module and also we have several receiver modules. So if you didn't take the receiver, you can also take this receiver. Thank you.
Question?
So the question is about speed. The baud rate was 9,600 bit per second.
Все, ответили на вопрос? Еще что там спрашивал? Да.
Yeah, 8 bits and 8 bits and then one stop bit. Yeah.
Yep.
Yeah, you can use this table for encoding and for decoding. So the data has to be decoded and encoded with this table. Thank you. More questions?
Any questions? Yeah, actually, there were no separation between teams, so flags were asked from some other teams. So every team has the same flags. So it was plain, no description, no authorization. And Igor here gonna present his service. And the next service is
Cleaner. It looks like Mac is awesome too. Oh, much better. Okay, now looks like we're ready to begin. Cleaner is a service about cleaning robots. You can upload room configurations, robot programs, run them, and list. That's pretty everything you can do. The vulnerabilities was quite simple. The first one is when you upload room and program in one session, the password is moved through std move to temporary buffer when you calculate MD5. And all the programs are saved with empty password. So you can upload your room, empty room, for example, and run programs run our programs on your room and see the result and log. Second vulnerability was with program execution. You have a room plan, which is a two-dimensional array, and initial positions initialized to -1. Typically, in the first command, you pass the new command. You initialize state of robot. If you don't pass it, robot will start from the field will be underflown, and you can write at any position before the begin of the field of the room plan. Here you can do heap underflow if your room is quite huge, and such as room is stored inside the std string. If you pass small string, the small string optimization will occur, and the room plan will be stored on stack. So you have stack underflow, you can overwrite return address, or you can simply overwrite room name to program name to name of our programs, and if you get room later, the target program will be in output. So, and maybe the most difficult part was to determine where is the flag. Here was some part of steganography. If you now I show. If you cut one room, you'll see something like that. This is a room configuration. Now, if you see the source code, all the rooms have 8 columns and some rows. So all the checker rooms have 8 columns and 32 rows. So you need, and you know that all the flags ends with equal sign. If you cut more rooms, if you cut all more rooms and see at the last 8 characters of the room configuration, you may determine some pattern. Here V is a wall, and our characters is just trash. If you look at the bit representation of the equal character, you maybe see that if you reverse it, you will have ones at the positions of the walls. So every 8 bytes in a room configuration is reversed walls is on the positions of the 1 byte bit, and our characters code 0 bit. Also programs, if you run program with checker pass, every non-wall tiles will be program will go over all non-volatiles. So if you steal room configuration or program, you can get a flag. So that's all. Questions? По поводу флага? Flag — это конфигурация комнаты. Flag is a room configuration. And also the same flag has a program that encodes him. Флаг — это комната. Также есть команда, соответствующая этой комнате, которая тот же самый флаг. Да. Ну, да. Ну, так можно было только положить сервис. You can DDoS service by overwriting flags. Да. More questions?
Hi guys, my name is Troyenko Dmitry and I'm author of For Each Service. For Each Service is C# program with a lot of using of single awaits. And For Each has two vulnerabilities. The first one is using of untrusted data, which got from HTTP requests. The untrusted data is content length. Does anybody understood the purpose of reusable object pool? The purpose is to reduce memory traffic, which is a problem of GC runtimes. And the another purpose is to get vulnerability work. Each post request, each post HTTP request uses the buffer which is got from reusable object pool, and reusable object pool uses the concurrent stack. That's why each sequential requests got the same buffer, and the vulnerability is using of content length as the length of the data got from requests. This leads to using some data which got from previous requests, and you can post this data and then use this data and read it. This is my service, and here I have exploit. Exploit is simple. We get some post requests. We have post requests with content length set to some large value, 200, for example. And, the one issue which we must think about is CSRF token. But CSRF token is placed in first position in post requests, and we can override them with our value. And same token we must put in cookie. Another fields we can override is login and pass. And here we have some trashed value which it some unclosed value from previous requests, and some other values such as allergens which are posted in previous requests will be used in our requests too. Let's try to check it. We got cookies for our foodbot user. Let's try to log in. Foodbot. Our password is password. Oh. Our password is xxxx. Okay. Sign. Oh. Okay, we signed in, and what we see here is a response. Oh. Response. Нет. Something happens. Don't why. Let's try another. Another try. Remove our cookies. Okay. Let's put our flag and start. Request is forced. Oh. Okay. Something don't work, but this vulnerability is work. I checked it. Don't say why it don't work now. Is any questions for first vulnerability? The second vulnerability is in string matching, substring matching. It is here. What is the purpose of for each service? The purpose is to put some food and check it for allergens in ingredients. The allergens are matched by using index of function. How index of function work? It finds a substring in our string, but here we're using some Unicode words, and matching of Unicode words is quite hard task. And we know that there are some issues with cultures, and but another issue is using of some characters in substring, which we matching is some characters are unavailable for string matching. Here is example. We have a string in which we want to match some ton of bytes FF. And what is the result of this function? We think that -1, but no, the result is 0. The 0 position is the position of word with a ton of bytes inside ABC string. And what is the exploit of this vulnerability? We can register some user with allergen with value FFFFF and 31 byte of FFFF, or another byte which has the same things. And this substring will be matched in position of our flag. Why is that this? Because the flag and our substring are the same length, and match can occur only in position of flag. And flag will be posted to us in WebSockets, and we will see it and can read. I don't know, is it possible to check? There's our request for using this vulnerability. We generate some CSRF token and use some user, and allergen is FFFFFF. We register our user. Let's log in as this user. There's our allergens. Okay, let's try to put flag. And here is our flag, which is matched as substring of our big string with allergens. It is the second vulnerability. Is there any questions? Okay, thank you.
Hi. Там страничка выбора настроек. So the next service is SOX. Is the easiest one, I think. So it's only 200 lines. Yeah, and if you look through it, you can see there is two methods: search and set. So it's some kind of very small search engine. First of all, let's look to put method to see how it store data. So let's do something here. It's to save log file. It's not interesting at the moment. So let's see index method first. Index. Here it is. Here ID is a flag here. Owner is some string, and body is another string that checker sent to us. First of all, it's story ID in docs vector. ID is a flag, so flag is here in docs. And then it takes doc ID and remember it. And here it is. And here it takes every word in body and store it to index. You see, if it's so index is inverted index. I think you should know it's a base structure in search engine. You get word in K and vector of document IDs in value. Yeah. And after it indexes all the document body, it stores some interesting things. It stores a special fake word. So it's owner and it's string owner and owner, and it's put to the service put it in index 2. Yeah. So I think it's all about index function. So let's look to the search method. Yeah. Search methods. First of all, it modify request. It add special string with owner to the beginning of the request. So this is how it checks the owner. If you put wrong owner here, it won't be found, and the service says not found. So it put owner's special word to the beginning of the request, and then it go to search the search method. Let's look for it. Tick, tick, tick. Yeah. Yeah, here it is. It takes, it splits text through white spaces and text takes every word in it, and then when it found every word in index, and look here, it makes interception of all on all words in request. And there is one thing here. Look, first of all, it makes empty hash set of doc IDs, and then make yeah, here it is. It's an empty hash set of doc IDs, and then for every word, it makes interception of found doc IDs in index. But you can make interception with empty hash set. So here it is. It checks if doc ID is empty. It just stores it just put here the doc IDs from index. So here is the back here, because if word doc IDs is empty too, so you remember that the first word of text is owner. So actually, you can put any owner here which is not an index, and you can find some docs. But you still have to guess at least one word in document, because if you put no words or some random words, it will be not found. There is a two-way to do it. You can just brute force it. The easiest way to brute force is with numbers. Just put 1, 2, 3, 4. The second way is to get words from your own service, from your own image. You can find what's a checker put and use the same words to other team. So that's the only bug in this service. So that's all. Any questions? Okay. So.
I think that's all for the services right now, because we don't have one developer. Huh? Okay, yeah. Luckily, our team leader, who is late, can talk about the service.
Yeah, the last service which was not described was Blue Mesh. First of all, why it's Blue Mesh? So if you have tried this service, you understand why it's mesh, because it's kind of a mesh network between the teams, like maybe Tor network. But blue, it should be on the interface Bluetooth. But finally, we understood that it will be maybe too complex for this service. Actually, even without Bluetooth, the service was too complex, and we managed to fire it up only after the launch. So the key idea was that the checker puts information to the service via the random route of nodes. So all your nodes on different teams try to find each other, try to connect, to form some kind of a graph. And when the checker wants to put the flag to some team, the checker builds some kind of a random route and sends the information to the network. And it's routed with the help of kind of onion addressing. So the bug was in cryptography. We used some kind of very weak cipher with multiplication, which could be easily hacked by using Euclid method. I don't know how it's in English, Euclidean method. So yeah, the most complex part of this thing was to fire it up. And the bug was in the cryptography. So you could actually, though the flags were transported in an encrypted form, the encryption was weak, and you could easily decrypt them and get the flag. So yeah, that's all. Да. Yeah. The question was like, we somehow managed to see the flags in a plain form. Yeah. The thing is that when checker puts the flag, he first chooses the start node and transports flag there in unencrypted form. So those times when you were chosen as the third node in the root, you got the 3 flags. So all the teams who were just looking the traffic could easily find like 5% of flags. Are there any other questions? Yeah, okay. Так, все рассказали? Да. So actually the route, if I'm not mistaken, the route was chosen as the most short route, and you could protect yourself by connecting to the. Well, there also was a node on our system, on checker system, and the way to protect your service was to directly connect your service to the check system service. So the road to your service would be just direct link without other teams. Yep, we are showing you some kind of video. What this video may say?
It's a test of deploying the machines, the services on machines. So the notebooks are booted from network, and the operating system with vulnerable images is installed on each notebook. We were using Ansible to deploy the services.
Actually, we're gonna open the repo, as I might have mentioned before. I'm not sure when, but I think we'll post some update in some social networks also, so follow up. And I think you'll find something interesting there. Okay, so if you want to ask a question, feel free to ask. If you come up with a question later, feel free to contact any of us. We will be happy to help you. And I think that's it. And I remember may I remind you that there are receivers waiting for you. So thank you, everyone. Let's applause to each other. Great job. Hope you hope to see you next year. And don't forget about the receivers. We don't want to take them with us.